Back to another episode in the string series. Today we'll be looking at valid palindrome. Let's read the question. A phrase is a palindrome if, after converting all the uppercase letter into lowercase letters, that's our first rule, uppercase to lowercase, and removing all non-alphanumeric characters. So that means spaces, commas, colons, anything that's not an alphabet or a number. So remove alphanumeric characters, and if it reads same forward and backward, that means it's a palindrome. Alphanumeric characters include letters and numbers. So these are the two rules. We get our string, we remove all the characters, we convert everything to lowercase, we remove all the non-alphanumeric characters, or we can say we keep all the alphanumeric characters. And then we check if it reads backwards and forwards, and if it does, we would return true, and if it doesn't, it will return false. We can also see that when it's empty, we return true. And here this has commas and colons, so we have to remove that too. So let's jump onto the scratchpad and see real quick how we can do this. Okay, so there are a couple of ways to do this, but in the both of the ways we have to filter out all these characters like colon, comma, and like white spaces. So to do that, in Swift it's pretty simple. I'll show you. That's not it's a single liner, but after we do that, we'd get a array like this. And now how do we check if it's a palindrome or not? So the approach one is like the simplest approach. It's basically to check if cars is equal to reverse of cars. And that would essentially show you that if we flip this array, like this becomes the first element, that this becomes the last element. If it's a palindrome, this condition would satisfy. Okay, that's one way to check if it's a palindrome. Now another way is to loop through the entire array and check if at ith index is equal to the length of the array minus 1, okay, minus I. So that would mean if I is equal to 0 and length here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 minus 1 minus 0. That would mean it's 20. That means this index here, we check these two and then move on to the next one. And then we check these two and then move on to the next one. And then we check these two and then move on to the next one. Similarly, this and this, and then we keep going until we reach the middle point. First, I'll try to implement it with, because we can always look through the entire array, right? We can always look through the entire array and see, but after this point, which is roughly the middle ground, it will all repeat. So at this point, our condition would say this works, and then our left pointer would move here and our right pointer would go to this side, and it would check all these elements. But we've already checked these, so we can kind of skip them. So we can traverse through the half of the array and then check all the elements within that. Okay, so let's check that process out. on code. I'll be coding out both of them simultaneously. So I'll see you there. Okay, let's look at the solution. The approach one, filter and reverse. So to filter these characters, we initialize a cars constant and convert s into an array with lowercase elements. And once we have this, we would filter this out to say, so in the filter hierarchy function, we can access the element like this, 0, and call like string functions on it depending on whatever kind of element it is. We can call string functions, string helpers, or int helpers if it's an int in the array. So here I want to say element is letter, or element is number. So in the filter block of code, if we return true, only those elements will show up in our new array. If we return false, that means it will skip them. Once we have these cars, this is all the entire array of filtered out single characters in S. So once we have this, the first approach was filter and reverse, right? So this is where the filter happens. Now the reverse here would be basically nothing except cars double equal to cars dot reversed. And that's literally it. That's the entire solution. Okay, that runs, submit. Okay, so that was the first approach. Now the second approach is filter and walk back in the elements, right? So we already have filter. Let's not delete that, let's keep it. Once we have the filter, what we can do is we can check if, actually we could check it for the previous scene also. Guard if characters are empty, else return not empty and return true. So if we get an empty array that's like this one here, we'd return true. Okay, so we have to walk back, right? So let's parse through the entire array. So for I in 0 dot dot cars dot count -1, if cars of I is not equal to cars of cars dot count -1 minus I. If that passes, we return false. Otherwise, outside this would return true. Now, notice that this will go through the entire array. I want to show you that this works too, but this is not efficient. We can parse through half of the array and get this done. So for this method, it's O of n, because you're looking at each character once. Given n is the number of alphanumeric characters in S. And once we have this, let's try and submit it and see if it works. What does this mean? Oh, okay, so close range. You want close range here. Okay, that ran, but this is still O of n. Can we improve it? What we can do is we can parse through half of the array. So let's say this here, just exactly like this. And that would only parse up until C. And at this point, we would have checked everything to the right and everything to the left. everything to the left, and that should work. Okay, let's give this a run. Okay, that works too. Awesome. Yeah, and that's the solution to this problem. Let me know if you have any questions. If you like this video, do give it a thumbs up and please consider subscribing. It really helps me, and I'll be posting more videos very soon.